Tonight, there's a quiet question waiting for you, one that no telescope has ever fully answered. What if the universe is older than we think? Not just by a little, but by something so vast, it would rewrite the entire story of existence. Because right now, scientists say the universe is about 13.8 billion years old. That number feels precise, comforting even. But what if it's wrong? What if everything we believe is the beginning, is only the middle of a much longer, stranger story? And if that's true, then where did it really begin? Or more unsettling, did it ever begin at all? Stay with me, because by the end of tonight's journey, we'll slowly uncover clues that hint at something deeper, something almost impossible to imagine. And if you enjoy these quiet explorations of the cosmos, take a moment to gently like the video and subscribe to the channel. It helps more curious minds find their way here, and it keeps these stories alive. Now, let your body relax, let your breathing slow, and let's begin. The age of the universe isn't something we can measure directly. We don't have a cosmic clock ticking somewhere in space. Instead, we piece it together, like detectives, using light. Very old light. There's a faint glow that fills the entire universe. A soft, almost invisible radiation left over from the earliest moments after everything began. It's like an echo, still traveling after billions of years. By studying that glow and how fast the universe is expanding, scientists arrived at that number, 13.8 billion years. But here's where things get interesting. Some of the oldest stars we've ever observed seem almost too old. Not dramatically, but just enough to raise eyebrows. Enough to make scientists pause and ask, wait, how is that possible? Because if a star appears nearly as old as the universe itself, or even slightly older, then something doesn't quite add up. Is the universe expanding at a slightly different rate than we think? Is dark energy, the mysterious force pushing everything apart, changing over time? Or is there something deeper we're missing entirely? This is where the first layer of mystery begins to open. Because in science, when numbers don't perfectly agree, it's often a sign that something new is waiting to be discovered. And sometimes, those small cracks lead to entirely new ways of understanding reality. Now imagine this. Not all planets belong to stars. Some are alone, drifting silently through the darkness of space, with no sun to warm them, no sunrise, no sunset, just an endless night. These are called rogue planets. They may have once belonged to solar systems, like ours, before being thrown out by gravitational chaos. A close encounter with another planet, or a passing star, can fling them into the void. Others may have formed completely on their own, like failed stars, never gathering enough mass to ignite. And here's the surprising part. There could be billions of them in our galaxy alone, possibly even more than the number of stars. Think about that for a moment. Entire worlds, oceans perhaps, frozen solid, atmospheres drifting in darkness, landscapes that have never seen light, all quietly wandering through space. And we barely notice them, because they don't shine. They don't reflect much light. They are almost invisible. So the universe isn't just full of stars and galaxies. It's full of hidden worlds. Worlds that drift, unnoticed, between the things we can see. And that leads to a deeper question. How much of the universe is still hidden from us? Because even the things we can see might not be telling the full story. Now let's take a step further. What if the universe didn't begin once, but many times? There are theories, still speculative but fascinating, that suggest the universe might go through cycles, expanding, slowing, collapsing, and then beginning again, over and over, not with a final ending, but with a kind of reset, like a breath, inhaling and exhaling across unimaginable spans of time. In these models, What we call the Big Bang might not be the true beginning. It could simply be the latest chapter, a transition from a previous universe into this one. And if that's true, then traces of older universes might still exist, hidden in subtle patterns, buried in the structure of space itself. We might be living inside a story that has already happened before, more than once. But if the universe has cycles, what carries over from one to the next? Does anything survive? Or is everything erased completely every time? That question still doesn't have an answer. Not yet. Now let's move even closer to the beginning, to a time when the universe was only about 380,000 years old. Before that moment, everything was different. The universe was filled with a dense, glowing fog, so hot, so packed with energy, that light couldn't travel freely. Photons, particles of light, were constantly colliding with charged particles, scattering in every direction. It was like trying to see through a thick, blinding mist. But then, something changed. As the universe expanded, it cooled. And for the first time, atoms could form. Simple ones, like hydrogen. And suddenly, the fog lifted. Light was free. That ancient light is still here today. It has traveled across space for over 13 billion years, stretched and cooled, now appearing as a faint microwave glow that surrounds us in every direction. You can't see it with your eyes, but it's there. Everywhere. A quiet reminder of the moment the universe first became transparent. And here's the strange part. That light isn't just a relic, it's a message, a snapshot of the universe. When it was still young, and hidden inside it are tiny variations, slight temperature differences that reveal how matter was distributed at the very beginning. Those tiny fluctuations eventually became everything. Galaxies, stars, planets, you, which means everything you are may trace back to the smallest ripples in ancient light. But that raises another question. If everything began from such simple conditions, why does the universe look so complex now? And even more curious, why does it look the way it does, and not some completely different way? We're only at the beginning of this journey, and already the universe is starting to feel less like a place, and more like a mystery unfolding layer by layer. And as we continue, we'll explore stranger worlds, invisible matter, bending light, and forces that quietly shape everything around us. Because the deeper we look, the more the universe begins to whisper something unexpected. That maybe we've only understood a small fraction of what's really out there. And yet, even that ancient light doesn't tell us everything. Because most of the universe is still invisible. Not hidden like those rogue planets drifting in darkness, but fundamentally unseen. Not because it's too dim, but because it doesn't interact with light at all. This is where we step into one of the deepest mysteries in all of science. Dark matter. Right now, as you're listening, something is passing through your body. Not once, not occasionally, but constantly. Trillions of particles, every second, moving silently through you, through the walls around you, through the entire earth. And you feel nothing, no warmth, no pressure, no trace at all. Because dark matter doesn't behave like normal matter. It doesn't absorb light. It doesn't emit it. It doesn't reflect it. It's completely invisible. And yet, it has mass. It has gravity. Which means, even though we can't see it, we can feel its influence. Galaxies rotate too fast, far too fast, for the amount of visible matter they contain. If only stars and gas were holding them together, they should have flown apart long ago. But they didn't. Something unseen is holding them in place, like an invisible scaffold. shaping the universe from behind the scenes. And here's the unsettling part. We still don't know what it is. Not exactly. We have ideas, hypotheses, experiments buried deep underground, detectors waiting in silence, hoping that one of these particles will finally leave a trace. But so far, nothing definitive. Which leads to a quiet but powerful realization. Everything you've ever seen, every star, every galaxy, every glowing cloud of gas makes up only a small fraction of what actually exists. The rest is hidden. So here's the question that begins to unfold. If most of the universe is invisible, how much of reality are we truly experiencing? And how much is happening? Just beyond our reach? Now imagine this. You're looking at a distant galaxy through a telescope, a faint smudge of light, billions of light years away. But what if I told you that sometimes you're not seeing it just once? Sometimes you're seeing it multiple times, at the same time, from different angles. That sounds impossible at first, but space itself isn't flat. It bends. Massive objects, like clusters of galaxies, warp the fabric of space-time around them. And when light passes through that warped region, its path curves, like a beam of light passing through a glass lens. This effect is called gravitational lensing, and it creates one of the strangest illusions in the universe, the same galaxy, appearing in multiple places, sometimes stretched into long arcs, sometimes smeared into glowing streaks, sometimes forming perfect rings of light. But these aren't copies. They're different journeys. Light from that one galaxy, taking multiple paths through curved space, arriving at Earth along different routes. And sometimes, those paths are not equal in length, which means we might see the same event more than once. Imagine a distant star exploding in a supernova. Its light splits, traveling along different curved paths. One arrives first. Another, years later, to us, it looks like the same explosion, happening again. The universe replaying itself. Not because time reversed, but because light took a longer way home. Now pause on that idea for a moment. Light can get lost. It can wander through space, delayed, bent, redirected, and still arrive, carrying a message from the past. So when you look at the night sky, you're not just seeing distance. You're seeing history, layered, distorted, and sometimes repeated. And that brings us to another quiet revelation. The universe is not just strange in what it contains. It's strange in how it shows itself. Now let's go back much further, to the very first stars. Not the ones we see today, but the ones that existed before anything familiar. These stars were different. They formed from a simpler universe, made almost entirely of hydrogen and helium. No heavy elements, no carbon, no oxygen, none of the building blocks we associate with planets or life, because those elements didn't exist yet. These were the first generation of stars, and they were enormous. Hundreds of times more massive than our sun, brighter, hotter, and incredibly short-lived. They burned through their fuel at an almost unimaginable rate, shining millions of times brighter than the sun, before collapsing in violent explosions. And in those final moments, something extraordinary happened. They created the first heavy elements, carbon, oxygen, iron, everything needed to build planets, oceans, and eventually living beings, which means every atom in your body, heavier than hydrogen, was forged inside a star that lived and died long before the Earth existed. You are, quite literally, made from the ashes of ancient stars. But here's the twist. None of those first stars still exist. They lived fast, and they died early. All we have left are their subtle chemical fingerprints, scattered through space, so we've never seen them directly. We've only inferred their existence from the traces they left behind. It's like reconstructing a story from echoes. And that leads to another question. If the first stars are gone, what else has disappeared without leaving a clear trace? No, consider something even stranger. There are galaxies that glow, but contain almost no stars. At first, that sounds contradictory. Galaxies are supposed to be collections of stars. That's how we define them. But some of these systems are different. They're filled with gas and dark matter, but very few stars. Barely enough to make them visible. Some may have lost their stars, stripped away by gravitational interactions. Others may have never formed many at all, which challenges one of our basic assumptions, that galaxies naturally create stars. Apparently, not always. Some galaxies exist in a kind of quiet state, holding mass, but not shining brightly, almost like ghosts. And when astronomers observe them, they raise uncomfortable questions. If these galaxies have the right ingredients, why didn't they light up? What prevented them from becoming what we expect? And once again, the universe offers no clear answer, only more curiosity. So now, we've opened several threads. What is dark matter, really? Why does light sometimes take multiple paths, bending reality itself? Where did the first stars come from? And what else have we lost to time? And why do some galaxies remain dark, even when they shouldn't? We won't answer all of these yet. Not completely. Because the universe doesn't reveal itself all at once. It unfolds slowly, layer by layer. And in the next part, we'll follow these threads even deeper, into places where gravity becomes extreme, where time itself begins to stretch, and where reality starts to behave in ways that feel almost impossible. Because the deeper we go, the more the universe begins to feel less like a place and more like a question, waiting to be understood. But if gravity can bend light, what else can it bend? Because once you follow gravity far enough, you arrive at something even stranger. A place where not just space, but time itself begins to change. Black holes. At first, they sound simple. A region of space where gravity is so strong, nothing can escape, not even light. But that description is only the surface. Because a black hole doesn't just pull things in, it reshapes reality around it. Imagine you're far away from a black hole, watching from a safe distance. Everything seems normal. But as you move closer, something subtle begins to happen. Time slows down, not in a poetic sense, not in the way we say time flies or time drags, but literally. If you were hovering near the edge of a black hole, what physicists call the event horizon, time for you would pass more slowly compared to someone far away. Minutes for you could be hours or even years for someone watching from a distance. And this isn't science fiction. It's been measured in weaker forms, even here near Earth using precise atomic clocks. Gravity stretches time. So near a black hole, time doesn't stop completely, but it slows more and more as you get closer. From the outside, it would look like you're freezing in place, your movement slowing, your light fading, until you appear almost suspended at the edge, never quite crossing, just lingering. But from your perspective, you would continue forward, unaware of this dramatic slowdown, which raises a quiet but unsettling thought. Two observers, watching the same moment, would not agree on what is happening. Time is no longer universal. It becomes personal. And that leads us to a deeper question. If time can stretch and slow and differ depending on where you are, then what is time? Really? Now let's go even further. Because black holes don't just affect time, They can also erase things, or at least hide them. When something crosses the event horizon, it disappears from our view. Completely. No signal, no light, no information escapes. It's as if that object has been removed from the universe we can observe. But here's the paradox. According to the laws of physics, information should never be destroyed. So what happens to it? Does it remain trapped inside? Does it somehow get encoded on the surface of the black hole? Or is our understanding of physics incomplete? This is one of the biggest unsolved problems in modern science, and we don't have a final answer. Not yet. Now imagine something even more dramatic. Two black holes, drifting through space, slowly drawn toward each other. At first, nothing seems unusual. They're invisible, silent, but as they get closer, something extraordinary begins to happen. They start to orbit each other, spinning faster and faster, like two dancers, pulled together by gravity, and as they move, they send ripples through the fabric of space-time itself. These ripples are called gravitational waves. They travel outward, across the universe, carrying energy, not as light, but as distortions in space and time. Imagine dropping a stone into a still pond. The surface ripples outward. Now imagine that pond is the universe itself, and instead of water, it's space-time. When those black holes finally merge, in a single, brief moment, they release more energy than entire galaxies, but not in light, in waves, waves that pass through everything, through planets, through stars, through you. And in 2015, for the first time, we detected them. A tiny signal, a subtle stretching and squeezing of space itself. Measured by instruments so precise, they could detect changes smaller than the width of a proton, which means we can now listen to the universe in a completely new way, not just through light, but through the vibrations of reality itself. And here's the beautiful part. Every collision tells a story of massive objects meeting, merging, and becoming one. Events that happened billions of years ago, finally reaching us as faint whispers in space-time. So now, another thread opens. If space-time can ripple, if it can stretch, bend, and carry waves, then what is it made of? Is space-time truly continuous, or is it built from something deeper, something more fundamental? We don't know yet, but the questions are getting closer. Now let's shift perspective again, away from black holes and into something quieter, but just as strange. Empty space, or what we think is empty. Because even in the deepest voids, far away from stars, galaxies, and gas, space is not truly empty. According to quantum physics, what we call nothing is actually full of activity. Tiny particles and their opposites, constantly appearing and disappearing, incredibly fast, too fast to observe directly. They flicker into existence, then vanish again, like brief sparks in a dark room. These are called quantum fluctuations, and they happen everywhere, all the time, which means even in complete darkness, even in perfect emptiness, something is always happening. And here's where it gets even more fascinating. Some scientists believe these tiny fluctuations in the earliest moments of the universe were stretched by rapid expansion, becoming the seeds of everything we see today. Galaxies, clusters, the entire cosmic web, which means the largest structures in the universe may have begun as the smallest, most random events imaginable, a flicker, a fluctuation, a moment of instability in what we call nothing. And that leads us to one of the most profound ideas in all of science, that everything may have come from almost nothing, but not quite nothing, something deeper, something unstable, something waiting to become. Now pause here, because 3 questions are now quietly unfolding together. What is time, if it can stretch and slow? What is space-time, if it can ripple and bend? And what is nothing, if it's never truly empty? We're not going to answer them all at once. Not yet, because the universe doesn't reveal its secrets in a straight line. It circles back. It layers meaning. It lets you feel the mystery before it gives you clarity. And in the next part, we'll explore places even colder, even emptier, where galaxies fade into darkness, where motion continues, even in stillness, and where the universe begins to hint at how it might eventually end, or whether it ever will. Because the deeper we go, the more one quiet idea starts to take shape, that the universe is not just expanding in space, it's expanding in mystery. But what happens when everything goes quiet? Not just a silent night, not just empty space between stars, but a universe where almost nothing is left to shine. Because if we follow the story of the cosmos far enough into the future, we begin to see something unsettling. Not an explosion, not a sudden ending, but a slow, quiet fading. This is where we begin to explore one of the most haunting possibilities, the heat death of the universe. Now, despite the name, it's not about heat in the way you might expect. It's actually about the loss of usable energy. In physics, there's a concept called entropy. You can think of it as a measure of disorder, or more precisely, how evenly energy is spread out. At the beginning of the universe, energy was uneven, clumped, concentrated, which allowed things to happen. Stars formed, galaxies gathered, light ignited, structure emerged. But over time, energy spreads out. It evens itself. And when energy becomes completely uniform, nothing interesting can happen anymore. No gradients, no flows, no processes, just stillness. Now imagine this on a cosmic scale. Stars burn out, one by one, not all at once, but slowly, across trillions of years. The bright, vibrant universe we see today becomes dimmer, quieter, colder. New stars stop forming, because the gas needed to create them has already been used up, or scattered too thin. Galaxies grow dark, and what remains are stellar remnants. White dwarfs, neutron stars, black holes, silent and cold. But even that isn't the end, because over unimaginable timescales, even those remnants begin to change. White dwarfs cool, fading into black dwarfs. Neutron stars lose energy, and black holes begin to evaporate. This might sound surprising. Black holes are known for pulling things in, not giving anything back. But due to quantum effects near their edges, they slowly lose mass, a process so slow, it takes longer than the current age of the universe by a factor so large, it's almost impossible to comprehend. But eventually, even black holes disappear, and what's left? A universe with no stars, no structure, no light. Only a thin, cold bath of particles, spread almost perfectly evenly across space. No gradients, no differences, no change, just equilibrium. And in that state, time itself becomes meaningless. Because time is measured by change. If nothing changes, what does it mean for time to pass? Now pause here, because this introduces a deeply unsettling idea. The universe doesn't end with a bang, it ends with a whisper. But is that truly the final outcome? Or is there something else, still hidden in the math? Because there are other possibilities, some more dramatic, some even stranger. Let's explore one of them. What if the expansion of the universe doesn't just continue, but accelerates faster and faster over time? Right now, observations suggest that the universe is expanding at an increasing rate, driven by something we don't fully understand. Dark energy, a mysterious force, pushing space itself apart. And if that force continues to grow stronger, it could lead to something called the Big Rip. In this scenario, the expansion becomes so powerful that it begins to tear everything apart. Not just galaxies moving away from each other, but galaxies themselves being pulled apart, then star systems, then planets, then atoms. Eventually, even the fabric of space-time is ripped. Everything dissolves, not into darkness, but into separation and infinite stretching, until nothing remains connected to anything else. Now imagine that moment. Not a collapse, not silence, but a kind of disintegration, where distance itself becomes infinite, even between things that were once touching. And once again, we're left with the question: which future is correct? A slow fading into stillness, or a violent tearing apart, or something else entirely? Because there's another possibility. That feels almost like a return to the beginning. What if the universe doesn't expand forever? What if, at some point, it stops and begins to contract, pulling everything back together, galaxies reversing their motion, space itself shrinking, temperatures rising again, until everything collapses into a dense, hot state, not unlike the beginning we described earlier. This is sometimes called the Big Crunch. And if that happens, could it lead to another beginning, another expansion, another universe, a cycle, repeating endlessly? We don't know. But the idea introduces something fascinating, that endings might not be final. They might be transitions. Now let's bring this back to something more immediate. Right now, in this moment, the universe is not empty. It's active, dynamic, full of light, motion, and change. Stars are forming, galaxies are colliding, black holes are merging. You exist in a brief window of cosmic history where the universe is alive with structure, because in the far past, it was too hot, too simple for complexity to exist, and in the far future, it may be too cold, too uniform for anything to happen. Which means, right now is special, not in a mystical sense, but in a physical one. You are living in a time where the universe is capable of producing observers, of asking questions, of reflecting on itself, and that leads to a quiet, almost philosophical realization. The universe has become aware of itself, through you, through every conscious mind, looking up at the stars and wondering. And yet, we still don't know how the story ends, or if it truly ends at all. So now, the three questions we've been carrying begin to evolve. If time can stretch, what happens to it at the end? If space-time can bend, can it also break? And if nothing is never truly empty, could something new emerge again? We're getting closer, but not quite there yet. Because in the next part, we'll move into something even more subtle. The nature of reality itself. Not just what exists, but how it exists. Because some of the strangest ideas in science suggest that reality might not be as solid or as continuous as it appears. And once you begin to see that, everything changes. Just a little. But what if reality itself isn't as solid as it feels? Because up to now, everything we've explored still assumes something quiet, something almost invisible in the background. That the universe is made of things. Particles, objects, stuff. But as we move deeper into the smallest scales imaginable, that assumption begins to fall apart. Welcome to the quantum world, a place where the rules are not just strange, they feel almost impossible. Imagine this. You take a single particle, something incredibly small, like an electron, and you try to observe where it is. Simple, right? But when you look closely enough, you discover something unsettling. Before you measure it, the particle doesn't have a single position. It exists in a range of possibilities. Not here, not there, but in a kind of spread out state, like a cloud of probability. Only when you observe it does it choose a position. Now pause on that, because it suggests something profound. That reality, at its deepest level, is not fixed. It's not determined until it's observed. And that leads to a question that has puzzled scientists for decades. What does it mean to observe something? Is it the act of measurement, interaction, or something even deeper, involving consciousness itself? We don't fully know, but the implications are enormous. Now let's take this one step further. Imagine a particle faced with two possible paths, like passing through two openings, side by side. In our everyday world, an object would go through one path or the other, never both. But in the quantum world, the particle behaves differently. It doesn't choose one path. It takes both at the same time, not by splitting into two pieces, but by existing in a superposition of states. And when those paths recombine, they interfere with each other, creating patterns, like overlapping ripples in water. Which means the particle somehow explored both possibilities simultaneously. Now here's where it becomes even more unsettling. The moment you try to observe which path it took, that behavior disappears. It suddenly behaves like a normal object again, choosing one path, as if the act of observation changes reality itself. Now think about that for a moment. At the smallest scales, reality doesn't fully exist in the way we expect until it's measured. So what does that mean for the universe as a whole? Because everything we see, every star, every galaxy, every structure is built on top of these quantum foundations, which behave in ways that defy our intuition. Now let's introduce another idea: quantum entanglement. Two particles created together can become linked, not just in proximity, but in state, so that measuring one instantly affects the other, no matter how far apart they are. They could be separated by vast distances, even across the galaxy, and yet they remain connected. Change one, and the other responds immediately, not after a delay, not at the speed of light, instantly, which seems to violate one of the most fundamental limits in physics, that nothing can travel faster than light. But entanglement doesn't send information in the usual way. It's as if the two particles are not truly separate, as if they are part of a single system, even when spread across space. And that leads to a deeply unsettling possibility. That separation might be an illusion. That, at a fundamental level, the universe might be more connected than it appears. Now imagine extending this idea, not just between particles, but across everything. Every interaction, every structure. A hidden layer of connection, binding the universe together. We don't fully understand it, but experiments continue to confirm that entanglement is real, and that it behaves exactly this way. Now let's take a breath here, because three new questions have quietly emerged. If reality depends on observation, what defines an observer? If particles can exist in multiple states, what determines the outcome? And if everything might be connected, what does separate really mean? We won't answer them all at once, because each one opens a deeper layer. Now let's move into something even more subtle. The idea that reality might not be continuous, it might not flow smoothly, but instead be made of tiny, discrete units, like pixels in an image, or frames in a film. At first glance, the universe feels continuous. Motion is smooth. Time flows seamlessly. But at extremely small scales, there may be limits, minimum lengths, minimum times, beyond which the concepts of space and time stop making sense. Think of it like zooming in on a digital photo. At first, everything looks smooth. But as you zoom further, you begin to see individual pixels, blocks, units. If space-time works this way, then what we perceive as smooth reality could actually be built from something granular, something fundamental. And here's where it becomes even more intriguing. Some theories suggest that space-time itself might emerge from something deeper, not the foundation, but a result, like a pattern emerging from simpler rules, which raises one of the boldest ideas in modern physics, that space and time might not be fundamental at all. They might be byproducts of something we don't yet understand. And if that's true, then everything we experience, every distance, every moment, could be part of a deeper structure hidden beneath our perception. Now pause again, because the questions are becoming more abstract, but also more profound. What is reality made of, if not particles in space? What is time, if it's not fundamental? And what lies beneath everything we can observe? We're getting closer to the edge, where physics begins to meet philosophy, where explanation becomes speculation, but also where new discoveries often begin. And in the next part, we'll go even further, into ideas that challenge not just how the universe works, but why it exists at all. Because once you begin to question reality itself, a deeper mystery begins to emerge. Not just how things happen, but why there is something instead of nothing. But why is there something instead of nothing? Not just as a poetic question, but as a real physical puzzle. Because everything we've explored so far, stars, galaxies, space-time, even quantum fluctuations, still assumes one thing: that existence is already here. But what if we go one step deeper? What if we ask not how the universe works, but why it exists at all? Now, at first glance, this might feel like a question without an answer. But surprisingly, physics has started to approach it, carefully, quietly. And what it's beginning to suggest is both simple and deeply unsettling. Because in some models, nothing is not stable. Let that sink in. We tend to imagine nothing as empty, quiet, permanent. But in quantum physics, nothingness may actually be unstable, like a perfectly balanced object that can tip without warning. Even in what we would call empty space, there are still fluctuations, tiny, unavoidable, spontaneous changes. And under the right conditions, those fluctuations could grow, expand, become something, which leads to a radical idea that the universe may have emerged from a kind of quantum instability, not from a cause in the traditional sense, but from the fact that absolute nothingness might be impossible to maintain. In other words, the universe didn't need a reason to begin. It may have begun because it couldn't not begin. Now pause here, because this shifts the question entirely. Instead of asking, why does something exist? We begin to ask, could nothing ever truly exist? And if the answer is no, then existence is not an exception. It's the default. Now let's go further. Because once a universe begins, something else may happen. It may create more universes. There are theories, still speculative, but taken seriously, that suggest our universe might be just one of many. A multiverse. Not a metaphor, but a literal collection of universes, each with its own properties, its own laws, its own structure. Some might be similar to ours, others completely different. In some, gravity might be stronger. In others, weaker. In some, atoms might not form at all. In others, stars might burn differently, or not exist. And most of these universes would be empty, lifeless, chaotic. But a few, just a few, might have the right conditions for complexity, for structure, for observers. Which brings us to a curious idea, known as the anthropic principle. It simply states, we observe the universe the way it is, because if it were different, we wouldn't be here to observe it. At first that might sound circular, but it has a strange kind of logic. If there are countless universes with different properties, then it's not surprising that at least one has the right conditions for life, and we happen to be in it. But that raises a deeper question. Is our universe special, or are we simply in a rare but inevitable pocket of possibility? Now let's connect this back to something we've already explored. Those tiny quantum fluctuations that may have seeded galaxies could also, under the right conditions, create entire universes, like bubbles, forming in a larger cosmic field, each one expanding, becoming its own reality, its own space-time, its own story, which means our universe might not be the whole picture. It might be one bubble in a vast, unseen ocean. And beyond our observable horizon, there could be others, forever out of reach. Now pause again, because three threads are starting to converge. If nothing is unstable, then something must exist. If universes can emerge, then there may be many. And if many exist, then our universe may not be unique. But we're not done yet, because there's another idea, even more unsettling. What if the laws of physics themselves are not fixed? What if they can change? Right now we treat physical laws as constant, reliable, universal. Gravity works the same way everywhere. The speed of light is constant. Quantum behavior follows consistent rules. But what if these are not absolute? What if they are local, emerging like patterns within a larger system? In that case, different regions of a larger reality could operate under different rules, different constants, different possibilities, which would mean what we call the laws of physics might be more like habits, stable patterns. That happen to exist here, but not necessarily everywhere. Now imagine that, reality, not as a single set of rules, but as a landscape of possibilities, with different regions behaving differently. And our universe is just one stable configuration. Now let's bring this back to something more immediate. You. Right now, listening. Your thoughts, your awareness, your experience, all of it, emerging from the same universe that may have begun from a fluctuation, expanded from instability, and formed structure over billions of years, which leads to a quiet but profound realization. You are not separate from the universe. You are a continuation of it, a process that began long before you were born and will continue long after. The atoms in your body were forged in stars. The patterns in your brain follow the same physical laws that shape galaxies. And your awareness, your ability to ask these questions, is part of the universe, trying to understand itself. Now pause here, because the questions we've been carrying are changing again. If something must exist, is existence inevitable? If there are many universes, what determines their nature? And if laws can vary, what lies beneath them? We're getting closer to something deeper than explanation, something that feels almost like a boundary. And in the next part, we'll approach that boundary, where physics, mathematics, and philosophy begin to blur together. Because at the deepest level, the question may not just be, what is reality? But why does reality make sense at all? But why does reality make sense at all? Not perfectly, not completely, but enough. Enough that patterns repeat, enough that equations work, enough that we can predict what will happen next. Because when you really stop and think about it, there's no obvious reason the universe has to be understandable. It could have been chaotic, inconsistent, impossible to describe, and yet it follows rules. rules that can be written down, tested, refined, and used to unlock deeper layers of reality. Now pause on that for a moment, because this is one of the quiet miracles of existence. The universe is not just there, it is knowable, at least in part. And that leads to a question that scientists and philosophers have both asked. Why? Why should the universe follow laws at all? Why should mathematics? Something abstract, something created in the mind, so perfectly describe the physical world? This question doesn't have a simple answer, but it opens the door to something fascinating. The idea that mathematics might not just describe reality, it might be reality. Now that sounds strange at first, but consider this. Every physical law we've discovered, from gravity to electromagnetism to quantum mechanics, can be expressed mathematically, not approximately, but precisely. The equations don't just model reality, they predict it, often before we even observe it, which suggests something deeper, that the structure of the universe is fundamentally mathematical. Not made of things in the traditional sense, but of relationships, patterns, information. Now imagine that. Instead of thinking of the universe as a collection of objects, think of it as a network of interactions, a web of relationships, where what matters is not the stuff, but how that stuff connects and evolves. In this view, particles are not tiny solid spheres. They are excitations, disturbances, in underlying fields like ripples in a deeper medium. And those fields follow mathematical rules. So what we perceive as reality is the visible expression of invisible structure. Now here's where it gets even more interesting. Information. At its core, physics may not be about matter or energy, but about information. What can be known? What can be measured? What can be distinguished? And how those distinctions change over time. Some physicists even suggest that the universe is fundamentally made of information, not particles, not fields, but bits of information, interacting, evolving, processing, almost like a computation. Now this leads to a provocative idea. What if the universe is not just governed by laws, but is itself a kind of process, a computation unfolding over time? Not necessarily like a computer we build, but something deeper, a system that updates its state, moment by moment, following consistent rules, which raises an unusual question. If the universe is a kind of computation, what is it computing? We don't have an answer, but the question itself changes how we think about reality. Now let's connect this back to something more familiar. Patterns. Think about waves in the ocean. No single water molecule defines the wave. The wave is a pattern, a behavior, moving through the water. Similarly, what if particles are not things, but patterns? Stable patterns in a deeper structure, which means what we call objects might just be persistent patterns in a constantly changing system. Now take that one step further. You, your body, your thoughts, your identity, all of it could be seen as patterns, stable for a time, but always changing, are always evolving. And yet, from the inside, it feels continuous. It feels real, because the pattern persists. Now pause here, because three threads are converging again. If reality is mathematical, then what gives rise to those structures? If everything is information, what defines that information? And if we are patterns, what does it mean to exist? We're getting closer to something that feels almost like a boundary. Now let's step into something even more abstract. The idea that reality might not just be described by mathematics, but that all possible mathematical structures exist. Not just one universe, but every possible universe, defined by every consistent set of rules. In this view, Our universe is just one realization, among countless others, each one equally real, in a broader sense. Now this is a bold idea, and it's still debated, but it offers a strange kind of explanation. Why does our universe have these laws? Because those are the laws of this particular structure. Not chosen, not designed, but simply one of many possibilities. Now imagine that reality, not as a single story, but as a library, an infinite collection of possible worlds, each one following its own logic. And we find ourselves in one where complexity and awareness can arise. Now let's bring this back again to something simple, a moment, right now. You're listening, processing words, forming images, feeling ideas unfold. All of that is happening within the universe, but also reflecting it, because your mind is part of the same system, trying to understand itself, and that creates a loop. The universe observing the universe through you. Now pause on that, because it's one of the most subtle ideas in all of this journey. The observer is not separate from reality. It is embedded within it, which means any attempt to fully understand reality must include the observer as well. And that complicates things, because now the system we're trying to understand includes us. Now the questions shift again. If reality is mathematical, why these equations and not others? If everything is information, who or what defines it? And if the universe can observe itself, is that observation fundamental? We're very close now to the edge of what we can comfortably explain. And in the next part, we'll cross that edge just a little further, into ideas that challenge not just physics, but the nature of perception itself. Because what if the reality you experience is not the full story, but a filtered version of something much deeper? What if what you're experiencing right now is not reality itself, but a version of it? Not a false illusion, not a simulation in the simple sense, but a filtered view, a translation. Because everything you see, everything you hear, everything you feel is processed. Your brain doesn't show you the world as it is. It shows you a model, a simplified, efficient, survival-oriented version of reality. Now think about that. Light enters your eyes, but you don't see wavelengths. You see color, air vibrates, but you don't hear pressure waves. You hear sound. Molecules interact with your body, but you don't feel atomic forces. You feel touch. Every sensation is an interpretation, a reconstruction built inside your mind, and it works beautifully. It keeps you alive. It helps you navigate the world, but it raises a quiet, unsettling question. If your perception is a model, then what is it modeling? What does reality look like? Before it's translated? Now let's go deeper. Because your brain doesn't just passively receive information. It predicts. Constantly. Based on past experience, it generates expectations about what you're about to see, hear, feel. And then it compares those predictions to incoming signals, adjusting, refining, updating the model, which means you're not just seeing the world, you're actively constructing it, moment by moment. Now imagine this. Two people standing in the same place, looking at the same scene. Are they experiencing the same reality? Not exactly. Their brains, their histories, their expectations shape what they perceive, subtly, quietly, but meaningfully. So even at the human level, reality is already personal, filtered, interpreted. Now extend that idea further. What if our entire experience of the universe is shaped by the limits of our perception? We see a narrow band of light. We hear a limited range of sound. We sense only certain types of interactions. There could be layers of reality, completely invisible to us. Not because they're hidden, but because we're not equipped to perceive them. Just as a radio can't detect light, and your eyes can't detect radio waves. There may be aspects of the universe that exist but never enter our awareness. Now pause here, because this connects back to something we explored earlier. Dark matter. It interacts gravitationally, but not with light, which means an entire component of the universe is already invisible to us. We detect it indirectly through its effects, but we don't experience it. And that might just be the beginning. Now let's take another step. Because some scientists and thinkers have suggested something even more radical, that what we perceive as reality is not just incomplete, but optimized, shaped by evolution, to prioritize usefulness, not truth. In other words, your perception doesn't show you what's real, it shows you what's useful, like a user interface. Think about your computer screen. You see icons, folders, windows, but those aren't the actual processes happening inside the machine. They're simplified representations, designed to help you interact with a complex system. Now imagine that your perception of reality works the same way. Space, time, objects, these could be the icons of a deeper reality that we never see directly. Now, this doesn't mean reality is fake. It means what we experience is not the full picture. It's a layer. Now let's connect this to something even more subtle. Consciousness. Your awareness. The feeling of being here, experiencing, observing. Science can describe brain activity. Neurons firing, signals passing, patterns emerging. But the experience itself, the feeling of seeing color, of hearing sound, of being aware, that's something else. Something we don't fully understand. This is sometimes called the hard problem of consciousness. Why does physical activity in the brain produce subjective experience? Why isn't it all just processing without feeling? We don't have a complete answer, but it suggests something important. That consciousness might not be easily reduced to simple physical explanations. Now imagine this. If consciousness is fundamental in some way, then observation might play a deeper role in reality than we currently understand. Remember earlier when we talked about quantum systems and how observation seems to affect outcomes? Some interpretations suggest that the act of observation is tied to awareness itself. This is still debated, still unclear, but it raises a fascinating possibility. That consciousness is not just a byproduct of the universe, but part of how the universe operates. Now pause here, because the threads are tightening. If perception is a model, then reality is deeper than we see. If observation matters, then consciousness may be fundamental. And if our experience is filtered, then the universe may be far richer than we imagine. Now let's go one step further. What if different forms of consciousness perceive different versions of reality? An insect, a bird, a human, each with different sensory systems, different brains, different models, each experiencing a different slice of the same underlying world, which means reality, as we experience it, is not fixed. It's perspective dependent. Now extend that idea even further. What if there are forms of awareness, very different from ours? Not human-like, not biological, but still capable of perception. Would they experience the universe in completely different ways? Would their reality look nothing like ours? We don't know. But the possibility is there, and it opens something profound. That reality might not have a single appearance, only many perspectives. Now let's bring everything together, just for a moment. The universe may be made of information, structured by mathematics, emerging from quantum foundations, expanding through space-time, and perceived through limited, filtered systems like ours, which means what you experience is real, but not complete, and the deeper truth may be far more complex, far more subtle, and far more beautiful than anything we can directly see. Now the questions evolve again. If reality is filtered, what lies beyond the filter? If consciousness plays a role, what is its true nature? And if perception shapes experience, how many versions of reality exist? We're now standing at the edge where science begins to blur into something more philosophical, more introspective. And in the next part, we'll take a step into that space where the question is no longer just about the universe out there, but about the experience of being within it. Because the deepest mystery may not be the cosmos itself, but the fact that it can be experienced at all. But what does it actually feel like to exist? Not in theory, not in equations, but in direct experience. Because everything we've explored so far, space, time, matter, information, perception, still circles around something central. The fact that there is an experience at all. Right now, there is something it feels like to be you. There is awareness, a sense of presence. And that may be the deepest mystery of all. Not the universe out there, but the experience happening within. Now imagine something simple. A universe with no observers, no minds, no awareness. Stars would still form, galaxies would still collide, black holes would still merge, physics would continue, uninterrupted. But there would be no experience of it, no color, no sound, no sense of time passing, just processes, without perception. Now compare that to the universe as you experience it. Rich, vivid, filled with sensation, meaning, awareness. The difference between those two is not in the structure of the universe, it's in the presence of experience. So what is that? What is this inner world? That seems so immediate, so undeniable, and yet so difficult to explain. Now let's explore one idea. That consciousness is not something added on top of the universe, but something that emerges from complexity. As systems become more organized, more interconnected, more capable of processing information, at some point, experience appears. Not gradually, but suddenly, like a threshold. Below that threshold, there is no experience. Above it, there is. But here's the problem. We don't know where that threshold is, or what defines it. Is a simple system conscious? A network? A brain? Where exactly does awareness begin? We don't have a clear answer. Now consider another possibility. That consciousness is not something that emerges, but something fundamental, like space, like time, like energy. In this view, consciousness doesn't arise from matter. Matter arises within consciousness. Now this idea is more philosophical, but it's taken seriously in some circles, because it tries to explain something that physical descriptions struggle with, why there is experience at all. Now imagine that. Instead of consciousness being a small feature of a vast unconscious universe, it is a basic ingredient, present in some form, everywhere. Not necessarily in the way humans experience it, but as a fundamental aspect of reality. Now pause here, because this changes everything. If consciousness is fundamental, then the universe is not just a collection of objects. It's a field of experience. And what we call matter is one way that experience organizes itself. Now let's bring this back to something more grounded, your own awareness, right now. You don't experience neurons firing. You don't experience electrical signals. You experience thoughts, images, feelings, a continuous flow of experience. And yet, that experience is somehow connected to physical processes, which suggests a deep relationship between the inner world and the outer world. But we don't yet understand how that connection works. Now let's take another step, because there's something even more subtle. The sense of self, the feeling that you are the one experiencing, that there is a center, a point of awareness from which everything is observed. But if you look closely, that sense of self is also constructed. It changes over time. It depends on memory, on perception, on identity, which means the you that experiences is not fixed. It's dynamic. A pattern, just like everything else. Now imagine this. If the sense of self is a pattern, then what happens when the pattern changes? When it fades? When it dissolves? Does experience end, or does it continue in another form? We don't know. But it raises a profound question. Is consciousness tied to identity, or is it something deeper? Now let's connect this to the universe again, because earlier we explored the idea that the universe might observe itself through us. Now we can ask a deeper version of that idea. Is the universe aware? Not in a human sense, not with thoughts or intentions, but in the sense that experience exists within it. And if consciousness is fundamental, then perhaps the universe is not just a system, but a kind of experiencing process. Now pause here, because this brings us to three final threads in this part. What is experience at its core? What is the relationship between mind and matter? And what is the nature of the self? That seems to observe everything. We're not going to answer these directly, because they may not have simple answers, but we can explore them. Slowly, carefully. Now let's end this part with a simple reflection. Right now, you are aware. You are listening. You are part of this unfolding story, not separate from it, but inside it. And that alone is something remarkable. Because out of all the processes in the universe, out of all the particles and forces and structures, there exists this quiet phenomenon, experience. And in the next part, we'll take one more step into a question that feels almost impossible, but impossible to ignore. Not just what the universe is or how it works, but whether it has a direction, a purpose, or if meaning itself is something we create along the way. But does the universe have a purpose? Not a poetic one, not something we project onto it, but something real, something built into the fabric of existence itself. Because once you begin asking not just how things happen, but why, you arrive at a question that feels almost unavoidable. Is all of this going somewhere? Now, from a scientific perspective, the universe doesn't appear to have a goal. There's no clear direction, no final state it's trying to reach. Physics describes what happens, but not why it should happen. Stars don't form with intention. Galaxies don't evolve with purpose. They follow laws. They respond to conditions. And yet, something interesting emerges from all of this. Patterns of increasing complexity, from simple particles to atoms, from atoms to molecules, from molecules to life, and from life to awareness, which raises a subtle question. If the universe has no purpose, why does it produce things that create purpose? Now imagine this. In the early universe, there was no meaning, no goals, no intentions, just energy, expanding, cooling, organizing. And yet, over time, structures formed, and eventually, systems emerged that could care, that could assign meaning, that could ask questions like this one. So perhaps, purpose is not something the universe begins with, but something that appears as complexity increases. Now think about that. Meaning, not as a fundamental property, but as an emergent one, something that arises when systems become capable of reflection. In other words, the universe may not have a purpose, but it creates beings that can create purpose, and that shifts the question entirely. Instead of asking, what is the purpose of the universe? We begin to ask, what is the purpose we create within it? Now pause here, because this is where science quietly hands the question to something else, to philosophy, to experience, to you. Because meaning is not found out there, in distant galaxies, or hidden equations. It's created here, in choices, in actions, in awareness. Now let's explore something deeper. Time, because purpose implies direction, a movement from past to future. But earlier, we saw that time is not absolute. It can stretch, slow, even behave differently depending on where you are. So what does it mean for something to have a direction in a universe where time itself is flexible? Now consider this. At a fundamental level, many physical laws are time symmetric. They work the same way, forward or backward, which means, in theory, the equations don't prefer a direction. And yet, we experience time as moving forward, always forward, from past to future, never in reverse. Why? The answer seems to be connected to entropy, the same concept we explored earlier, the tendency for systems to move from order to disorder, from low entropy to high entropy. This gives time a direction, not because time itself flows, but because change happens in a preferred way. Now here's the subtle connection. Purpose is something we project onto that direction. We move forward in time, and we create goals. We imagine outcomes. We assign meaning to what lies ahead, which means purpose may not be built into time, but built into how we experience it. Now let's take a step even deeper, because there's another possibility, that what we call purpose is linked to something more fundamental. Information. Remember earlier, we explored the idea that the universe might be made of information. If that's true, then processes that increase complexity, that generate new patterns, that create new forms of organization, could be seen as meaningful in a different sense. Not emotionally meaningful, but structurally, as if the universe is exploring its own possibilities. Now imagine that, the universe, not moving toward a goal, but unfolding, exploring all that it can become. Every star, every planet, every life form, every thought, a branch in a vast tree of possibilities. In you are one of those branches. Now pause here, because three threads are coming together again. If purpose is not fundamental, but emergent, then meaning is something we create. If time has a direction, then purpose is tied to how we move through it. And if the universe explores possibilities, then existence itself is a kind of unfolding. Now let's bring this back to something simple. Your life, your choices, your experience. In a universe that may not have a predefined purpose, you are free to define your own, not arbitrarily, but meaningfully, through connection, through curiosity, through understanding. And that might be one of the most powerful ideas of all. That meaning is not given. It is created. Now let's introduce one more subtle thought. Even if the universe has no ultimate purpose, the fact that we seek purpose may itself be meaningful, because it reflects something about us, about consciousness, about the drive to understand, to connect, to make sense of things. And that drive is part of the universe too. Now pause again, because we're approaching something important. If meaning is created, then it matters. Even in a universe without inherent purpose, the experiences we have, the connections we form, the questions we ask are real, and they shape the story. Now the questions evolve once more. If purpose is not built into the universe, what gives rise to it within us? If time gives direction, what do we choose to do with it? And if existence is unfolding, what role do we play in that unfolding? We're getting close now to something that feels like a conclusion, but also like a beginning. And in the next part, we'll bring these threads together, not to give final answers, but to see the bigger picture. Because after everything we've explored, there's one quiet realization waiting to be seen. that the mystery of the universe is not just out there, it's right here with us. But what if the biggest mystery was never out there to begin with? What if it has always been right here? Because after everything we've explored, cosmic expansion, dark matter, quantum uncertainty, consciousness, meaning, there's a quiet pattern beginning to emerge. A pattern that connects the very large with the very small, the universe with you. Now imagine this. Every atom in your body was once part of something else. A star, a cloud of gas, a distant explosion billions of years ago. Those atoms traveled, they combined, they became part of a planet, and eventually, they became part of you. So in a very real sense, you are not just in the universe, you are of it. A temporary arrangement of ancient matter, but it goes deeper than that, because it's not just your body, it's your mind. The same physical laws that shape galaxies also shape the patterns in your brain. The same rules that govern particles also govern the signals that create thoughts, which means there is no clear boundary between you and the universe, only different scales of the same process. Now pause here, because this changes something fundamental. The universe is not something separate that you observe from the outside. You are part of the system, observing itself from within. Now let's explore that idea more carefully. Earlier, we talked about observation in quantum physics, how the act of measurement seems to play a role in determining outcomes, and we wondered, what defines an observer? Now we can ask a deeper version of that question. What if the observer is not a special external entity, but simply a complex system within the universe, interacting with other parts of it? In that case, observation is not something added to reality. It is part of reality, a natural consequence of interactions between systems, which means the universe doesn't need an outside observer. It observes itself through its own complexity, through structures like brains, like minds, like you. Now think about that. Every time you look at the night sky, every time you wonder about existence, that is the universe, turning inward, reflecting on itself. Now let's take this one step further, because there's something even more subtle happening. Feedback. The universe creates structures that can understand it, and those structures change how the universe evolves. Through technology, through knowledge, through action. For example, humans have built telescopes that can see further into space, particle accelerators that can probe deeper into matter. We've extended our senses beyond their natural limits, which means the universe is not just passively observed, it is actively explored by parts of itself. And that exploration feeds back into the system, changing what happens next. Now pause here, because a new idea is forming. The universe is not static. It is not a finished object. It is a process, an ongoing unfolding. That includes observers who influence that unfolding. Now let's connect this to something more personal. Your choices, your actions, they may feel small, insignificant on a cosmic scale, but they are part of this process, part of the unfolding. Because the universe doesn't just evolve through physical forces, it also evolves through decisions made by conscious systems. Now imagine that. The story of the universe is not just written in stars and galaxies, but also in thoughts, in actions, in moments like this, which leads to a quiet but powerful realization. You are not just witnessing the universe, you are participating in it. Now let's step back for a moment, because several threads are converging again. The universe may have begun from simple conditions, but it has produced complexity. That complexity has produced awareness. That awareness can reflect, understand, and act, which creates a loop, a feedback loop. between the universe and itself. Now let's ask a deeper question. Where does this lead? Is there a direction? To this increasing complexity? To this growing awareness? Or is it simply one possible path? Among many? We don't know. But we can observe something interesting. Over time, the universe has become more structured, more organized, at least in certain regions. Life has emerged, intelligence has developed, and with it, the ability to understand. Now, this doesn't necessarily imply purpose, but it suggests a pattern, a tendency, toward complexity under the right conditions. Now imagine extending that pattern. What might exist in the far future? More advanced forms of intelligence? More complex systems? New ways of perceiving reality? Possibly, but also uncertainty. Because the same universe, that allows complexity to arise, also moves toward entropy, toward disorder, toward equilibrium. So there is a tension between creation and dissolution, between structure and decay. And everything we experience exists within that balance. Now pause here, because this brings us back to something simple. This moment, right now, you are part of this balance, a temporary pattern, in a vast evolving system. And yet, from your perspective, this moment matters. It has meaning. It has experience, which means even in a universe without a fixed purpose, there are still meaningful moments, still meaningful experiences. Now let's take one final step in this part, because there's a quiet idea waiting beneath all of this. The idea of perspective. From the outside, the universe may appear as a vast impersonal system, but from the inside, it is rich with experience, with awareness, with meaning. And both views are true. They are not in conflict. They are two ways of seeing the same reality. Now the questions evolve once more. If we are part of the universe, what does it mean to understand it? If observation is internal, what does it mean to know something? And if the universe is unfolding through us, what role do we play in that unfolding? We're getting very close now to the final pieces of this journey, and in the next part, we'll begin to bring everything together. Not as a conclusion, but as a deeper understanding, because the more we explore, the more one quiet realization becomes clear, that the mystery was never just out there. It has always been here with us. What does it mean to truly understand the universe? Not just to describe it, not just to predict it, but to understand it. Because up to this point, we've gathered pieces, fragments of a much larger picture. We've explored space, time, matter, energy, information, consciousness, and each one reveals something real, something consistent. But none of them feel complete on their own. It's like trying to understand an entire landscape by looking through a narrow window. You see something true, but not everything. Now imagine this. You have a map, a detailed, precise map of a territory. It shows distances, coordinates, structures, relationships. But no matter how accurate it is, the map is not the territory. It represents it. It approximates it, but it is not the thing itself. And in many ways, science works like that. It builds maps, models, equations, frameworks, each one capturing part of reality, but never the whole. Now pause here, because this introduces something subtle. All knowledge is model-based. We don't access reality directly. We construct representations of it, useful, powerful, but always incomplete. Now let's take this further, because different models can describe the same reality in different ways. For example, light can be described as a wave. It can also be described as a particle. Both models work. Both predict outcomes correctly. And yet, they seem to contradict each other. So which one is true? In a sense, both are, and neither is complete. They are perspectives, different ways of capturing behavior. Now extend that idea. What if all of our theories are like that? General relativity describes gravity beautifully at large scales. Quantum mechanics describes particles with incredible precision at small scales. But when we try to combine them, they don't fully agree, which suggests something important, that our current models are not the final picture. They are pieces, parts of a deeper structure that we don't yet fully see. Now imagine that, reality, not as something we've already figured out, but as something still unfolding, still being discovered. Now let's connect this back to you, because you are also a kind of model. Your brain builds a model of the world based on perception, memory, prediction, and that model is what you experience as reality. So in a way, you are always interacting, not with reality directly, but with your internal representation of it. Now pause here, because this leads to a profound realization. Understanding is not about perfectly capturing reality. It's about building models that are useful, that work, that allow us to navigate, predict, and explore. Now let's go deeper, because there's another layer. Limits. There may be things that we cannot know, not because we haven't discovered them yet, but because they are fundamentally inaccessible. For example, we cannot observe beyond the observable universe. There is a limit to how far light has traveled since the beginning. Beyond that horizon, there may be more, but we cannot see it. Not now. Possibly not ever. And that's just one example. There may be limits built into reality itself, limits to measurement, limits to precision, limits to knowledge. Now think about that. There may be aspects of the universe that are real, but forever beyond our reach. Now let's take this even further. Gödel's incompleteness theorems, originally in mathematics, suggest something intriguing, that in any sufficiently complex system, there are truths that cannot be proven within that system. Now apply that idea metaphorically to the universe. If we are part of the system, trying to understand the system, there may be truths that we cannot fully derive from within it, not because they don't exist, but because of our position inside the system. Now pause here, because this brings us to something subtle, almost paradoxical. We are trying to understand the universe from within the universe, which means we are both the observer and part of what is being observed. Now let's bring this back to something simple. A question. When you ask, what is the universe? You are using concepts, language, models, all created within the universe itself, which means every answer is part of the system, describing itself. Now this doesn't make understanding impossible, but it means understanding has layers, degrees, perspectives. Now let's gather the threads again. We have models, but not the full picture. We have knowledge, but also limits. We have understanding, but always from within. And that leads to a quiet conclusion, that the mystery of the universe is not something that disappears as we learn more. It transforms. It deepens. Now let's shift the feeling slightly, because this might sound like a limitation, but it's also something else. An invitation to keep exploring, to keep asking, to keep refining our models. Because even if we never reach a final answer, the process itself reveals more and more of the structure, more and more of the beauty. Now imagine that. The goal is not to eliminate mystery, but to engage with it, to move through it, to understand more, while accepting that there may always be more beyond. Now pause again, because 3 final threads are forming in this part. What does it mean to know something, if all knowledge is model-based? What are the limits of understanding, if we are inside the system? And what lies beyond those limits, if anything at all. We are now very close to the final stages of this journey. And in the next part, we'll begin to bring everything together, not as a final answer, but as a perspective, a way of seeing the universe and your place within it. That holds all of these ideas at once, because sometimes understanding is not about finding one answer, but about seeing how everything connects. How do all of these pieces fit together? Not as separate ideas, but as one coherent picture. Because up to now, we've explored the universe in layers: space, time, matter, energy, information, perception, consciousness, meaning. Each one revealing something true. Each one expanding our view, but also fragmenting it, like looking at a mirror, broken into many pieces. Each piece reflects something real, but none show the whole image. So now, in this part, we begin to gently bring those pieces together, not to force a final answer, but to see the connections, to see the pattern beneath the patterns. Now imagine this. Instead of thinking of the universe as made of things, think of it as made of relationships. Everything we've discussed can be understood in terms of how things relate. Space is about distance between events. Time is about the order of change. Matter is patterns of energy. Energy is the capacity for change. Information is the distinction between states. Consciousness is the experience of those distinctions. And meaning is what emerges when those experiences are interpreted. Now pause here, because something subtle is happening. All of these concepts are not isolated. They are different expressions of a deeper structure, a structure based on connection, interaction, relationship. Now let's take a step deeper, because earlier we explored the idea that the universe might be made of information. Now we can refine that idea. It may not just be information, but relationships between information, not bits, but connections, not static data, but dynamic processes, which means the universe is not a collection of objects. It is a network, a vast, evolving network of interactions. Now imagine that. Every particle, every field, every event is a node in this network, connected, interacting, influencing, and constantly changing. Now think about where you are in this picture. You are not outside the network. You are a part of it, a complex, dynamic pattern within the system, experiencing, interpreting, responding. Now pause again, because this shifts something fundamental. The boundary between self and universe begins to soften, not disappear completely, but become more fluid. You are not separate from reality. You are a localized expression of it. Now let's connect this to time, because earlier we saw that time is not absolute. It depends on perspective, on motion, on gravity. Now we can add another layer. Time may not be a thing that flows, but a way of describing change. Within the network, a sequence of updates, state after state, moment after moment, which means the universe is not moving through time. It is evolving as time. Now think about that. Time is not a background. It is the unfolding of relationships. Now let's connect this to space. Space may not be an empty container, but a structure of relationships. Distances, defined not by empty gaps, but by how things interact. Some theories even suggest that space itself emerges from deeper connections, like a fabric woven from interactions. Now imagine that. Space, time, matter, all emerging from a deeper layer of relationships. Now pause here, because the picture is becoming clearer, not complete, but more unified. Now let's bring in consciousness, because this is where things become truly interesting. If the universe is a network of relationships, then consciousness maybe a particular kind of pattern within that network, a pattern capable of experiencing, reflecting, modeling. Now think about what your mind does. It builds relationships between ideas, between memories, between perceptions. It creates a model of the network from within the network, which means consciousness is not separate from the structure of reality. It is a reflection of it, a localized mirror of the larger system. Now pause again, because this leads to something profound. When you understand something, you are not just observing it. You are aligning your internal model with the external structure. You are becoming, in a small way, synchronized with reality. Now let's connect this to meaning, because earlier we explored the idea that meaning is not built into the universe, but emerges. Now we can see why. Meaning arises when a conscious system interprets relationships, when patterns are recognized, when connections are understood. So meaning is not separate from the universe. It is a process that happens within it. Now imagine that. The universe, not just existing, but being experienced, interpreted, given meaning from within. Now let's step back and look at the whole picture for a moment. The universe begins in a simple state. It evolves through interactions. It forms structure. That structure becomes more complex. Complexity gives rise to awareness. Awareness builds models. Models create meaning, and meaning feeds back into the system through action, a continuous loop. Now pause here, because this is the pattern beneath everything we've explored. A cycle of emergence, interaction, reflection, and evolution. Now let's bring this back to something very simple. This moment, right now, you are listening, processing, understanding. All of that is part of this cycle, part of the universe understanding itself. Now the questions that remain are no longer just scientific, they are experiential. What does it mean to be part of this network? What does it mean to understand, even partially? And how do we live knowing that we are both observers and participants? We're very close now to the final stage of this journey. And in the next part, we won't introduce new concepts. Instead, we'll step back one last time and look at everything together as a single, quiet realization. Because sometimes the deepest understanding is not something we learn, but something we recognize. So what does it feel like to see the whole picture? Not perfectly, not completely, but clearly enough that something shifts. Because after everything we've explored, there comes a moment where the questions don't disappear, but they begin to feel different. Less like problems to solve, and more like something to sit with, something to experience. Now imagine this. You've been walking through a vast landscape at night, only seeing small parts at a time. A star here, a shadow there, a distant shape you can't quite identify. And slowly, as your eyes adjust, as the light changes, you begin to see more. Not everything, but enough to understand where you are. That's where we are now. Not at the end of the mystery, but at a place where the mystery becomes visible. Now let's bring everything together one last time. The universe began in a state we can barely comprehend. It expanded, it cooled, it formed structure, stars, galaxies, planets, and eventually bestowed life. That life became complex, aware, capable of reflection, and here you are, at the edge of that process, looking back, trying to understand it. Now pause here, because this is the quiet realization you are not separate from this story. You are its continuation. A moment where the universe becomes aware, of what it has become. Now let's go deeper into that feeling, because earlier we explored the idea that everything might be connected through relationships. Now you can start to feel what that means, not just intellectually, but intuitively. The air you breathe was once part of something else. The atoms in your body were forged in stars. The thoughts in your mind follow the same patterns that shape the cosmos. There is no clear line where the universe ends and you begin. Only a transition from one form to another. Now imagine that fully, not as an idea, but as a perspective. You are not in the universe. You are the universe, experiencing itself from a particular point of view. Now pause, because this is where something subtle happens. The questions change, they soften. Instead of asking, "What is the universe?" you begin to ask, "What is this experience?" Now let's stay with that for a moment, because experience is where everything comes together. All the physics, all the mathematics, all the theories they describe, but experience is what it feels like, and that feeling is immediate, direct, undeniable. Now consider this. You can doubt theories, you can question models, you can revise explanations, but you cannot doubt that experience is happening right now, and that makes it a kind of foundation, not of physics, but of perspective. Now let's connect this back to everything we've explored. The universe may be vast, complex, filled with mysteries, but all of it appears to you through experience, which means no matter how far you go in understanding, you always return to this moment, to this awareness. Now pause again, because this leads to a quiet shift. The mystery of the universe is not something far away. It is present in every moment of awareness. Now let's go one step further, because there's something even more subtle: acceptance. Not in the sense of giving up, but in the sense of recognizing that not everything needs to be resolved. That mystery is not a flaw in our understanding. It is part of it. The unknown is not an obstacle. It is the space where discovery happens. Now imagine that. Instead of trying to eliminate mystery, you allow it. You explore it. You move through it with curiosity rather than resistance. Now bring this back to something simple. The night sky. You look up, you see stars, points of light, distant, silent, and yet, now you know that each one is part of a vast structure, a network, a history, a process that you are also part of, which means when you look at the universe, you are not just seeing something external. You are seeing something that you belong to. Now pause here, because this is the feeling that remains. Not an answer, not a conclusion, but a perspective, a way of seeing that holds complexity without needing to reduce it. Now let's gather the final threads of this part. The universe is vast, but you are within it. The universe is complex, but you are part of that complexity. The universe is mysterious, and so are you. And that is not a coincidence. Now the questions that remain are not meant to be fully answered. They are meant to be lived, experienced, explored. And that brings us close to the final step of this journey. Not a final answer, but a final reflection. Because in the next part, we will not add more ideas. We will simply sit with everything we've seen and allow one quiet realization to come into focus. That perhaps the universe was never something to solve, but something to experience. And what if there was never anything to solve? Not in the sense that questions don't matter, but in the sense that the search itself was always part of the experience. Because as we arrive here, near the end of this journey, something subtle begins to settle. Not an answer, not a conclusion, but a kind of quiet clarity. The realization that every question we've asked has led us somewhere meaningful, even without final answers. Now imagine looking back. From the very first moment, we asked what the universe is. We followed it through space, through time, through matter, through energy, into the smallest scales, into the largest structures, into consciousness, into meaning, and finally, back to experience itself. And now we're here. Not at the end, but at a place where everything connects. Now pause here, because this is where something shifts. The journey was never just about understanding the universe. It was about expanding the way we see. Now let's stay with that for a moment, because perspective is everything. The same universe can be seen as cold, vast, indifferent, or as intricate, evolving, and deeply connected. Both are true, but they feel very different. Now imagine choosing a perspective, not blindly, but consciously. One that allows you to hold complexity, without needing to reduce it, one that allows mystery, without needing to eliminate it. Now think about your place in all of this. You are not just a passive observer, you are an active participant, a pattern, within a larger pattern, a moment of awareness, within a vast unfolding, and that means something. Not because the universe assigns meaning to it, but because you do. Now pause again, because this is where meaning quietly appears, not as something external, but as something created through attention, through curiosity, through presence. Now let's take a step even deeper, because there's something we haven't said directly yet. Everything we've explored, everything we've questioned, everything we've tried to understand has been happening within awareness. And that awareness has been constant. The content changes, the thoughts shift, the ideas evolve, but the fact that there is awareness at all remains. Now imagine that, not as an abstract concept, but as something immediate. You are aware, right now, and that awareness is the space in which the entire universe appears, from your perspective. Now pause here, because this is the quiet center of everything, not a place, not a theory, but an experience. Now let's connect this back to the beginning. We asked what the universe is. We explored its structure, its origins, its possible endings. We asked about reality, about perception, about consciousness, and now we arrive at something simple. The universe, as you know it, exists within experience. And experience is happening now. Now this doesn't answer everything. It doesn't explain every mystery, but it reframes them. Because instead of looking outward endlessly, you can also look inward, not to find answers, but to notice what is already here. Now imagine holding both directions at once, looking outward into the vastness of space and inward into the immediacy of experience. Both are real. Both are valid. Both are part of the same picture. Now pause again, because this is where the final threads begin to settle. The universe is vast, but it is also present. It is complex, but it is also immediate. It is mysterious, but it is also familiar. Now let's bring this to something very simple. Breathing. A quiet, constant process. You don't usually think about it, but it's always there, connecting you to the environment, to the larger system. In the same way, your awareness is always present, connecting you to everything you experience. Now imagine living with that awareness, not constantly analyzing, not trying to solve everything, but simply noticing. Being present, curious, open. Now this doesn't replace science. It doesn't replace exploration. It complements it, because understanding the universe is not just about knowledge, it's also about perspective. Now let's take one final step in this part, because there's a quiet realization waiting here. The search for understanding, the questions, the curiosity, they were never separate from the universe. They were expressions of it, which means the act of wondering is itself part of the answer. Now pause here, because this is where everything becomes very simple. You are here. You are aware. You are part of this unfolding. And that is enough to begin with. In the final part, we won't add anything new. We'll simply bring everything together into one last reflection, not to conclude, but to gently close the loop. Because sometimes the deepest understanding is not something we reach, but something we return to. And now, we arrive at the end, not an ending in the way we usually think, but a quiet point of return. Because after everything we've explored, every question, every idea, every layer of reality, we find ourselves back here, in this moment, aware, listening, present. In that might be the most important thing of all. Now imagine looking at the entire journey, all at once, the birth of the universe, from something almost incomprehensible, the expansion of space, stretching light across billions of years, the formation of stars, forging the elements that would one day become you, the emergence of galaxies, drifting through vast cosmic webs, the strange behavior of quantum particles, existing in possibilities, until observed, the bending of space-time, where gravity reshapes reality itself, the invisible presence of dark matter, holding everything together from behind the scenes, the slow fading of stars, toward a future we can barely imagine. And through all of that, something unexpected appears: awareness, experience, the ability to ask, what is all of this? Now pause here, because this is the thread that connects everything. Not just the universe as an object, but the universe as something experienced. Because without experience, there is no color in the stars, no silence in space, no sense of time passing, just processes, unobserved, and yet, here you are, experiencing it. Now let's take one final step deeper, because there's a quiet realization waiting here. Everything you've heard, everything you've imagined, everything you've understood has been happening within awareness, not somewhere else, not far away, but here, now. And that changes something, because it means the universe is not just something you are trying to understand. It is something you are part of, something you are participating in, something you are experiencing from the inside. Now imagine that fully. You are made of the same atoms as distant stars. You are shaped by the same laws that govern galaxies. You are part of the same unfolding process that began billions of years ago. And yet, you are also something unique, a perspective, a point of view, a moment where the universe becomes aware of itself. Now pause, because this is not just an idea. It's something you can feel. A quiet connection between you and everything else. Now let's gently bring everything together. The universe may not have a single answer. It may not have a final explanation. It may always remain partially unknown. But that doesn't make it empty. It makes it open, full of possibility, full of discovery, full of moments like this. And maybe that's the point. Not to reach the end of understanding, but to continue exploring, to continue wondering, to continue experiencing. Now think about that. Every question you ask, every idea you explore, every moment you notice is part of this larger process, the universe, learning about itself through you. Now let's slow down just a little, because this final moment is not about adding more. It's about noticing your breath, the quiet space around you, the feeling of being here, all of it. Simple, immediate, real. Now imagine carrying this perspective with you, not constantly thinking about the cosmos, but remembering that you are part of it, that your experience matters, that your curiosity matters, that your awareness is one of the most extraordinary things the universe has produced. Now pause one last time, because this is where everything settles. The mystery is still there. The questions are still open, but they no longer feel distant. They feel connected. Now, before we close, if this journey made you pause, if it made you think, if it made you feel even a small sense of wonder, take a moment to support the channel. Gently tap like, subscribe so you don't miss the next exploration, and share this with someone who might enjoy drifting through these ideas with you. And if a question stayed with you, something that kept echoing quietly in your mind, leave it in the comments. Because sometimes the most interesting journeys begin with a single unanswered question, and perhaps the next one we explore together will begin with yours. Now, as we come to the end, there's just one final thought to leave you with. Not an answer, not a conclusion, just something to sit with. The universe is vast, mysterious, unfinished. And somehow, within all of that, there is this moment, right now, where you are here, aware of it. And maybe that's not something to solve. Maybe that's something to experience. And as you move forward into the rest of your day, or into sleep, or into whatever comes next, remember this quiet possibility that the story of the universe is still unfolding. And you are part of that story.